Hey students, welcome back to my channel, Simple AlChemy, and today we are going to discuss some of the key points which you need to know to attempt 0620 paper 6, which is alternative to practical. The total marks of this paper are 40 and the weightage is 20%. The duration which will be given to you to attempt the paper is 1 hour. So let's start, and here are the topics according to the questions. So number one, you have apparatus and experimental techniques, separation methods, electrolysis, and energy changes. So these three, the first 3 points, they are related to question number one, which you need to know to attempt question number one, apparatus, experimental techniques. So today, this presentation will cover all of these things. Then we have separation methods, electrolysis. These are the part of question number one. Then for the energy changes, rate of the reaction, this is a part of question number two, because in question number two, you have to make the graph mostly. Then we have acid, base, and salt preparation, titration. This is also a part of question number two. After that, you have chemical analysis. In question number three, you need to identify the compounds by the given tests and observations. So the anion test, cation test, gases, and the flame test, they are all related to question number three. Then you have the last question, which is planning and investigation questions. So I'm going to give you some points to write this question also, to attempt this. So this is question number 4. Let's start. First of all, you need to know all of these apparatuses. How many of these apparatuses can you name? So here you go. The names of these apparatuses. Number one, this is a test tube. Number two, it's a beaker, a spatula, measuring cylinder, then burette, gas syringe. Number 6 is a gas syringe. Then we have pipette, thermometer, heat-proof match. All of these things are mentioned. Number 11 is the Bunsen burner. Number 12, this is wire gauze. Then you have retort stand, tripod stand, filter funnel, evaporating dish, watch glass. All of these things you can see over here, the pictures are made. So you can go through. Then fractionating column. Number 19 is a condenser, 20 is a conical flask. And whenever you have to write the name, then the name of the apparatuses, then always write full name, conical flask. Then you have round bottom flask, flat bottom flask. Okay, these are all the apparatuses. Then you have some more apparatuses. This is crucible, triangle, pipe clay triangle, which is not used in the experiments. Tongs, mortar and pestle, separating funnel, volumetric flask. Volumetric flask has a long neck. So you can identify that this is how this flask is different from the conical flask. Not from the conical flask, from the round bottom flask. How it is different from a round bottom flask? So the answer is that the volumetric flask has a long neck. So that's how it is different from round bottom flask. Then these are forceps, and this is teat pipette. Next, some more apparatuses. Now you should know that these apparatuses are used for what. So the last two, these two apparatuses, they are used to measure the volume of gas formed. Volume of a gas which is formed in the experiment. Mostly this is used in the rate of reaction experiments or in any experiment in which the gas is forming. So you need these apparatuses to collect and measure the gas. This gas should be insoluble in water. Okay, then you have this method to burn something. Note the difference between the gas jar, thistle funnel, and dropping funnel. Then separating techniques. Now, these are the separating techniques, and I think you will be familiar of these things. You have the filtration. For separating method, filtration, in which you have a liquid and insoluble solid mixture, you will separate it. And you should know that the substance which is left on the filter paper is called residue, and the one which passes out, the liquid part, is called a filtrate. Then you have this apparatus, which is a chromatography paper. You should know what is solvent line, what is solvent level. The solvent level is till till it travels, till the solvent travels. That is the solvent level, like to the end. And the baseline is the baseline, this one, on which you put the spot. This is called a baseline. And a solvent front is this till the solvent travels. This is called solvent front. Solvent front. Okay, so solvent front, RF value. How you will calculate the RF value? For the RF value, the formula is this: distance traveled by the solvent or distance traveled by the spot divided by the distance traveled by the solvent front. That's how you can calculate the RF value, which is also known as retention factor. Its full form is retention factor, and it is called RF value. And how to calculate it? We'll divide the distances. Which distance? The distance between the baseline and the spot divided by the distance between the baseline and the solvent front. Solvent front is till where the water or the solvent has traveled. Some more separating techniques. These are the two separating techniques, and you guys will be familiar of. These are distillation techniques. Distillation techniques. The first technique is for simple distillation, and the second one is for fractional distillation. You can see there is a condenser, a thermometer, a flask, and everything. Okay, then select the most suitable apparatus for the purpose. Now, how you should know that which apparatus is suitable one for this experiment? To measure the volume. Okay, to measure the volume, you have these things. You have these apparatuses. The first apparatus is called a measuring cylinder. The first apparatus is a measuring cylinder. The second apparatus is the burette. The third apparatus is the pipette. And the fourth one is a gas syringe. Now, which one is accurate? Burette and pipette. But you can see that the pipette has a limit of 25 centimeter cube. So if we want to measure the volume of a liquid above 25 degrees Celsius, above 25 centimeter cube, so we will use burette for that. So for example, if you want to measure 26 centimeter cube volume, or if you want to measure 30 or 32 or 35 centimeter cube volume, then you will use burette. So burette is more accurate for that. And then we have measuring cylinder. Its limit is also 50 centimeter cube, just like a burette. But the difference is that measuring cylinder is easy to use, but it is not accurate. Burette and pipette are accurate ones. These are the two apparatuses which are accurate. So a measuring cylinder is convenient to use, but the burette and pipette are accurate. Burette is used for titration, and pipette is used for a fixed volume. Gas syringe is used for gases. Then, how to read the instruments. Be careful with the units required. Now, how you will read? See, this is a picture of a clock or a stopwatch. Here, it is the small needle. It is indicating the minutes. And the big one, the long one, is indicating seconds. So if it is 0 minute, it's 0 minute. And for the second line, the seconds needle is on 45, 46, 47, 48. It is on 48. So it means it's 48 seconds, 0 minute and 48 seconds. For the second one, as you can see, the small line is on number one, small needle. So it's 1 minute. 1 minute is equal to 60 seconds. And for the second line, you can see it's number 5. It's 5, 6, 7, and 8. It's on 8 seconds. So it means we have 1 minute, 60 seconds, which is equal to 60 seconds, and 8 seconds, total 68 seconds. So that's how you will read it. (48 seconds and 68 seconds). Then Be careful with the burette readings. Here, the initial reading is 19, final reading is 32, and the difference will be 13. This is a burette reading which you read from the top. This also reading from the top. Note the inverted upside down scale. So here, the initial reading will be 2.7 and the final reading will be 23.1 and the difference will be 20.4. So that's how you will read it. Be careful with the reading that you will read from the top or from the bottom. Now, these are the apparatuses to measure or to collect the gases. So, how you will measure the gases? It can be this jar, downward delivery. It can be this jar, upward delivery, or it can be a jar like this. Okay, so here are some properties which are written, and according to them, you have to choose that which apparatus will be suitable for it. For example, if a gas is denser than air, so you will use this apparatus which is downward. So from the delivery tube, the gas comes and it comes down. It gets filled up inside. Then, and for example, sulfur dioxide, chlorine, and carbon dioxide. Then the gases which are less dense than air. So the gases which are less dense than air, they will be collected here. Their jar will be upside down. So they will go up from the delivery tube and will be collected upwards, like ammonia and hydrogen. And these will be mentioned to you in the question, that this is denser than air or this is less dense than air. Otherwise, if it is not mentioned, then if they ask you that is it denser or less dense, then you can see the apparatus, the diagram, and then you can identify. If it is upside down, then it will be less dense. If it be downward, then it is more dense. And you can use this apparatus, this inverted measuring cylinder on the water bath apparatus if the gas is insoluble or partially soluble in water. Because if the gas will be soluble in water, then it will dissolve in water and you'll not be able to collect it. So for example, you have oxygen, hydrogen, and carbon dioxide. Then use a gas syringe. You can also use measuring cylinder, but not gas jar. You can use a measuring cylinder if you want a graduated one, and if you want to measure the gas. To collect the gas, it's simple. You can use a gas jar. But to measure the gas also, then you have to use a measuring cylinder. Okay. Now, safety rules. If there are toxic gases produced like ammonia, sulfur dioxide, chlorine, bromine, iodine, all the halide, halogens, then the precaution will be fume cover. The experiment should be conducted in a fume cover. If the liquid is flammable, then you have to heat it in an electric heater instead of Bunsen burner. Electric heater, or you can also use a water bath to heat it. And if the substances are corrosive, then you have to use nitrile gloves. Okay. Note here that wearing safety goggles and lab coat are standard lab safety requirements in the chemistry lab. So no credit is given for this type of precaution. So if you write that we will stay safety goggles or if we will wear a lab coat, then this will not be, you will not get any mark for this, for writing this. Accuracy versus reliability. So for the accuracy means that how close your value, your answer is from the original value. How close it is with the original value. So here, as you can see in this diagram, all the points are closer to the original value. They are closer to the middle. So it means it's accurate, more accurate. And in picture number 2, as you can see, they are very far from the middle spot. So it means they are far from the results. They are less accurate. It is less accurate. And in the third diagram also, some of the results are closer, some of the results are far, so they are not as accurate. But what about reliability? Reliability is also known as precision. Precision is that how close the values are with each other. So if you repeat the experiment lots of time, it will be more precise or more accurate if your answers are closer to each other. Like in diagram number 1, the answers are closer to each other. So it means they are precise. Here also in number 2, the points are closer to each other. So it means they are precise. But in number 3, they are far from each other. So they are less precise. So here, the first one is accurate and reliable also. The second one is reliable, but it's not accurate. The third one is not accurate and not reliable. Not precise. Reliability means precision. Okay, if you need to improve accuracy, what will you do? Change the apparatus, burette instead of measuring cylinder, digital thermometer instead of mercury thermometer, calorimeter instead of naked eye, insulated polystyrene cup instead of beaker, cover with lid for experiments involving heat or chromatography. In plotting the graph, take more readings, more data, more accurate. So in most of the questions, in many of the questions, the burette one is there, the insulation one, and so in some of the experiments covered with this also. Okay, and in plotting the graph, if you take more readings, then your data will be accurate and your graph will be smoother. If you need to improve reliability, if you want the results of your answers to be same, like they're closer, if you want your results to be closer to each other, so you will do this. Repeat the experiment and take several results. Then drawing the graph, read the question carefully to determine the type of graph required. Is it a line graph or a curve? If you want to draw the line of best fit or a curve of best fit, or sometimes in line of best fit also you will draw a curve. Like in this one, in the question here, they will ask you to draw a smooth line graph, but what they do? A curve. So this is also possible, that sometimes you have to draw a curve according to your points, but they are asking you in the question to draw the line. Okay, read the question carefully, use X to plot, use sharp and dark pencil. Line graph can be straight line or curve. Keep this in your mind. Show how answers are obtained. Draw working lines. Okay, draw working lines like this. So if they ask you, in most of the questions, they ask you to work out something on the graph and find out something. So you have to work and write the answer here like this. Show your answers and show your working. Other points to note, leave out anomalous points. Bar chart, if there's a bar chart, leave space between columns, and very rarely bar chart comes. Two intersecting lines, draw two intersecting lines of best fit. Chemical analysis, some points to note in chemical analysis in question number 3. If it is water, if there is water of condensation at the mouth of the test tube, then what does it mean? A compound contains water of crystallization or compound is hydrated. This is very common in most of the questions they give this something like this, that when we heat the solid substance, condensation appears at the top of the test tube, at the mouth of the test tube. So it means that the substance is or solid is hydrated. If a substance is white when solid and colorless when dissolved in water, the compound contains a non-transition metal ion. If a compound is colored, that compound contains transition metal ion. These are the tests for the anions. It's given in the data sheet, and data sheet will be provided to you. Test for cations. Test for gases. Flame test. Note how to do the flame test correctly. The flame must be blue, roaring hot. It is important that there are no impurities present in the metal loop. So we have to clean the metal, clean the nichrome wire. Normally, a nichrome wire is used as a metal loop. To clean the metal loop, we dip in the concentrated hydrochloric acid before testing the metal. The flame test is possible for both the metal ion or metal element. Now, these are the chemical tests for the presence of water and hydrous copper sulfate, and it turns from white to blue. In hydrous cobalt chloride, and it turns from blue to pink. Okay. Test for acid and base. For acid, turns blue litmus red. Test for alkali, turns red litmus blue. Test for strong or weak acids and bases. For strongness or weakness, for the strength of acid and base, you should use universal indicator. and the colors of universal indicator, not thymophthalene or methyl orange. No, they are used in titration just to tell you that when the solution is neutral, when the solution is acid, base, or neutral. But thymophthalene, phenolphthalein, and methyl orange, they don't tell us the strength of acid and base. We can also use digital method. If using reactivity and conductivity to test strength of acid, it needs to be specific. Means you have to tell that what metal is this to make it a fair test. Okay, but these are the colors: universal indicator, phenolphthalein, and methyl orange. And in thymophthalene, when we use thymophthalene, then it is just the same as phenolphthalein, but instead of pink, its color will change into blue in the presence of alkali. Planning and investigation. Your first step is to plan the strategy. Okay. What is more pure, limestone or marble? Now, in this type of question, you need to identify that which one is purer. Calcium carbonate is found in limestone and in marble. So in both of the substances, calcium carbonate is found. All carbonates react with hydrochloric acid to form chlorides. Calcium carbonate is insoluble in water, but calcium chloride is water soluble. Most impurities in limestone and marble are insoluble. Plan an experiment to find out which of the limestone and marble contains most insoluble impurities. So which one contains most insoluble impurities? So how we'll do it? Suggested answer. Okay, take care of the language which is used and the levels of the details which are required. So you don't have to mention all of the story. Let's just give to the point answer. First of all, crush and grind the limestone using mortar and pestle. Weigh a fixed mass of powdered limestone. Add excess hydrochloric acid to the limestone to make sure that all the carbonate has reacted. Filter the mixture, keep the residue which consists of insoluble particles. Wash and dry the impurities. Weigh the impurities, record the mass. Repeat steps 1 to 6 using the same fixed mass of marble instead of limestone. Then compare the mass of impurities from limestone and marble. The one with the higher mass contains the most impurities. See, this question is so simple. So that's how you will write it. Very brief, very precise. Next, washing soda crystals are crystals of hydrated sodium carbonate. When exposed to air, some of the water is lost from the crystals, and a new substance is formed. This process occurs faster in hotter climates. So from sodium carbonate crystals, this water crystallization is lost due to heat, and sodium carbonate will be left. Plan an experiment to determine the percentage of water by mass present in a new substance. You are provided with a formal laboratory apparatus that how much water is left in that substance. So how you will do it? Leave some sodium carbonate crystals in the air. Warm the crystals in the water bath set at 30 degrees Celsius. Okay, so take some of the sodium carbonate crystals in the air, warm them, let the water evaporate. Weigh the crystals periodically until constant mass is reached. So you have to weigh the crystals 2-3 times until you will attain a constant mass. If the new substance is formed, record the mass of the new substance, and this is M1. So after heating, some of the water will be left in it, so you will weigh it. So you will weigh that substance. Heat the new substance with a Bunsen burner to drive away the remaining water of crystallization. Cool and re-weigh the anhydrous sodium carbonate. Okay, now you have to heat the new substance again, and you will reweigh it. Cool and reweigh the anhydrous one. Now no water is left in it. Repeat the heating to ensure that all of the water crystallization has been driven away. Cool and reweigh the anhydrous sodium carbonate. When constant mass is reached, record it as M2. The difference between M2 and M1 is the mass of water in the new substance. Now, if we want to take the percentage by mass, then what you will do? The mass of water, which is obtained after doing the minus, the mass of water which we obtain after doing M2 minus M1, this mass divided by the mass of the compound, this one, M1, the compound, the hydrated one, which contains a little bit of salt, a little bit of water in it, the mass of M1 multiplied by 100. So that's how you will take the percentage of any substance if you want to take mass of that substance divided by the mass of the total mass of the substance, in which we have to take the percentage multiplied by 100. So that's how you will take it. In the end, you have to mention that how you will obtain that thing, how you will fulfill that purpose. Some additional points they need to consider. Is it a fair test? For the fair test, you have to take equal volumes in all of the experiments. If you're comparing 2 or 3 substances, then to make it fair test, you have to take equal mass, equal volume, equal concentration of all of the substances. Are the calculations right? If they required any calculation, then you have to mention the calculation in the last step. Do I need to plot a graph to get the answer? Mostly no. Do I need to end with a conclusive statement? Yes, you have to write the end answer, that how you will, what is the requirement of the answer, that if you want to compare that, compare a substance, if you want to note down that how much amount of water or how much amount of this thing is present in it, so you have to mention it in the end. Conclude your answer. Remember that there is a lot of variation in this investigation questions. You need to be flexible in your thinking and planning. So you have to do a little bit of creative thinking. Then you have some points from the examiner's point of view. See, the candidates should use a sharp pencil for plotting points and drawing their lines of best fit on their graphs. This allows them to correct any errors. Points are best plotted with a cross to ensure that they are not obscured by either of the grid lines. Okay. Here, one of the main thing is that the question might require the line of best fit to be a curve or a straight line. So a line of best fit can be a curve, it can be a straight line according to the points. A straight line should be drawn with a ruler, but rulers should not be used to join the points on a curve. Lines of best fit should avoid anomalous points. Then whenever you write the observation, you have to write fizzing or effervescence or bubbles. If you write that the gas is given off, then you will not get the mark. You will not get the marks because you have to write the observation. In observation, you will write what you will see. So you can see the bubbles and fizzing, but you cannot see the gas. So smells such as pungent smell of ammonia or bleach or swimming pool smell of chlorine are also acceptable as observations. When a question asks for the name of a chemical, a correct formula is always acceptable. So if they ask you for the name of the chemical, you can write lithium sulfate, or you can also write Li2. So for like this also, it is correct, acceptable. However, if a candidate answers with the incorrect formula, then mark will not be awarded. So these are some of the points which I needed to cover, and you need to know to attempt this paper 6 of chemistry. So thank you for watching. Best of luck and subscribe.